In this class, we will derive expression of Boyle temperature. From equation of state other than van der Waals equation of state. In the previous video, we considered van der Waals equation of state. Namely, as well as the virial equation of state. And herefrom we derived expression of Boyle temperature to be in this class we will consider Berthelot's equation of state, and from it we will derive Boyle's temperature. Berthelot equation of state is Let us give it a simpler look through a bit of manipulation as follows. Dividing by n, this is what we get for the first term. And in the second term, we divide by n square to end up with this one. Let us now define V by N as Vm, which is the molar volume. So in terms of molar volume, Berthelot equation of state reduces to multiplying the entire equation by Vm by RT, as a result of which the left hand side of this Berthelot equation of state will become PVm by RT, which is nothing but compressibility factor. So the next step after multiplication gives us now this is Z, the compressibility factor. This Vm will cancel out one Vm and we have this expression. The first term on the right hand side can be written as and we can expand it and this is an infinite series. So collecting the terms, we have Z on the left hand side. This represents the first term, and the second term is an inspection of this equation reveals that the second term involves 1 by Vm and so does this last term. So taking 1 by Vm common from these two terms, we end up with this is what we have. After taking 1 by Vm as common, let us write the other terms. We can express the compressibility factor in terms of the virial coefficients as follows. Where A equal to 1. For B we can write, for C we have B square and so on. A, B, C being the virial coefficients. Again at Boyle temperature, the second virial coefficient is 0, as was discussed in the video on significance of Boyle temperature, and this means instead of T we write TB. From here we get the expression for Boyle temperature to be so this is Boyle temperature as follows from Berthelot's equation of state. We next consider Dieterici's equation of state. According to which we give it a simpler look through a simple manipulation through a division by n, and let us define molar volume and express the equation of state in terms of molar volume. Let us consider the compressibility factor, which is the ratio of PVM to RT. Putting expression of P and this gives RT cancels out, and this can be written as on the left hand side we have Z, expanding it we get and let us expand the exponential This refers to an infinite series, and so is this one. Multiply by 1, we get then we multiply with this term to get so the first term is 1. Let us take 1 by Vm common so that we have B and A by RT from here, and the other terms can be written, and we have an infinite series. And in terms of the virial coefficients, we can express Z as where A is 1 and the second virial coefficient is this one, and so on. At Boyle temperature, the second virial coefficient is 0, and therefore we have from here which gives so this is the expression for Boyle temperature. From Dieterici's equation of state.